Let's also take a look into one very simple example of neural networks. The example that I will explain here is to classify an MNIST database. An MNIST database is a handwritten digit database. So you're going to see some images like these ones. And these are some 28 by 28 grayscale images. And what we want to do here is we want to classify the digits of this image here. So for example, if this was 5, we want to make some prediction of our neural network to classify this to the number of 5. 0, 0, 4, 1. And let's talk about how we can actually implement this using Python. So the first thing that we need to do here is, since these are some image 28 by 28, and currently what we learned was MLPs. So we want to have some vector as the input feature. And what we can do here is we can flatten this matrix with the size of 28 by 28 to a vector with the size of 784 by 1. So we have some kind of flattened vector, like this one that includes the information of this handwritten digit image. So the network model that we're going to design will have the input layer of 784, the hidden layer with the number of neuron of 100, and the output layer with the number of 10. And what we're going to do here is we're going to do digit prediction in one-hot encoding, which means that if this is, for example, 5, we want to have a vector where this is for digit 0, 1, 2, 3, 4, 5, and so on. We want to have only 1 here and the other ones as 0. So this is called as one-hot encoding. And we can do this by implementing our model in Python. And here, firstly, we need to load our dataset. And thankfully, this dataset is actually already saved in Keras datasets. You can just load this MNIST dataset from Keras. And here, you can split these. These are already split in training and testing dataset. And you can just load this data here. And train X, test X, we're going to scale these by 255 because these has the these are integers from 0 to 255 because these are images, grayscale images. So if we divide this by 255, it'll be something from 0 to 1, a value from 0 to 1. And we're going to define our model like this one, where firstly we're going to flatten our input, where our input shape was 228 by 28, and then we're going to connect this flattened image to a dense layer, which has 100 hidden layer here. So this is the flatten function, and here this is the dense layer here, and the last layer will be dense layer with 10 neurons here. And the activation function, we're going to use ReLU for here and softmax for here. I didn't explain softmax, but this is an activation function that you can calculate the probability. And then what we're going to do is we're going to compile a model with the optimizer of Adam and loss as the sparse categorical cross entropy loss, which is frequently used for classification problem when we have a lot of classes. And the metrics that I'm going to save is the accuracy metric to evaluate the classification performances. And on our test data set, we can evaluate our model like here. So after training the model, we can do some evaluation. And for doing this evaluation, of course, we need to use some test image from our test data set. And when we're just doing some evaluation, you can use this prediction. Model.predict on batch test image. So for example, this test image could be something like 3, and this prediction will be a vector of a one-hot encoded vector like here. Like 0, 0, 0, 1, 2, 3, 0, 1, 0, something like this one. And if you just simply extract the maximum number, which will be 1 here, then you're going to extract the the index of the maximum number, you're going to be able to predict digit that was inputted as your test image here. So it will produce something like 3 here. 3 here. This is your probability. So let's try to do this and explain this using Colab. So this is the example of implementing the classification problem of our MNIST data set. So the first thing you need to do is to import your library. We're going to import TensorFlow, NumPy, and Matplotlib, and of course we also need to use Keras, TensorFlow Keras here. So first thing that we need to do is load our MNIST dataset. Here, MNIST equals to TensorFlow keras.datasets MNIST, and I explain all of these in our presentation slides. And define our neural network model, build our model using this one here, and define our loss and optimizer. We use the cross entropy loss here. This is defined as this one, and this is used for classification problems. And for the optimizer, we use our Adam optimizer. So here we compiled our model and then fitted our model on our training data set. And if you train this, you're going to see this kind of result. And if it's end, the train is ended. And then we can evaluate our model on our test data, test x, test y. And to plot one example in our test data sample, we can just simply choose one sample image from our test data sample. Because this is not a single image, this will be a set of images, and we've chosen one image here. So this will be some handwritten digit like number 3, which we looked before, and this example here, now it's 0. So this will be this image here. And if we put this image inside our model, and then extract the maximum index, then you're going to be able to see in our print result that this handwritten image is 0. So here, this is the lines to plot your handwritten digits, the image, original image, and the probability for that was predicted here. Predict 0.